Today we will discuss about C++ virtual function. A C++ virtual function is a member function in the base class that you redefine in a derived class. It is declared using the virtual keyword. It is used to tell the compiler to perform dynamic linkage or late binding on the function. There is a necessity to use the single pointer to refer to all the objects of the different classes. So we create the pointer to the base class that refers to all the derived objects. But when base class pointer contains the address of the derived class object, always executes the base class function. This issue can only be resolved by using the virtual function. A virtual is a keyword preceding the normal declaration of a function. When the function is made virtual, C++ determines which function is to be invoked at the runtime based on the type of the object pointed by the base class pointer. Late binding or dynamic linkage. In late binding, function call is resolved during runtime. Therefore, compiler determines the type of object at runtime and then binds the function call. Rules of virtual function. Virtual functions must be members of some class. Virtual functions cannot be static members. They are accessed through the object pointers. They can be a friend of another class. A virtual function must be defined in the base class even though it is not used. The prototypes of a virtual function of the base class and all the derived classes must be identical. If the two functions with the same name but different prototypes, C++ will consider them as the overloaded functions. As we saw in the previous lectures, we cannot have a virtual constructor, but we can have a virtual destructor. Consider the situation when we don't use the virtual keyword. Now we'll see an example where we don't use the virtual keyword. First, you create a class named capital A. In that, you write int x equal to 5. After that, under the public access specifier, we are writing a method void display of. In that, we are printing the value of x. After that, you are creating a derived class of the base class capital A, and you are writing colon public capital A. We can access all the public members of the base class. In the class B, we are writing int y equal to 10, and in the under the public access specifier, we are writing the same function void display of. We are printing the value of y. In the main function, you are creating a base class pointer star A, and you are creating an object of class B, and you are assigning the address of base class object to the base class pointer. Derived class object address you are assigning to the base class pointer. After that, you are invoking the display of function, then value of x is printed as the output. Why only value of x is printed means we are not using the virtual keyword, so using the base class pointer only base class function is invoked. In the above example, star A is the base class pointer. The pointer can only access the base class members but not the members of the derived class. Although C++ permits the base pointer to point to any object derived from the base class, it cannot directly access the members of the derived class. Therefore, there is a need of virtual function which allows the base pointer to access the members of the derived class. Now we will see another example. In that, we are creating a class capital A. Under the public access specifier, we are writing the virtual keyword. After that, we are writing void display of. In that, we are printing base class is invoked. After that, we are creating a class B, which is the derived class of class A. So we are writing colon public capital A. You can access all the public members of the class capital A. In class B, you are writing the public access specifier. Under the public access specifier, we are writing void display of. and we are printing derived class is invoked. In the main function, you are creating a pointer of the base class, and after that you are creating object of the derived class capital B. After that you are assigning the address of the derived class object to the base class pointer. After that you are invoking the display of function. Then you will get the output as derived class is invoked. Now the function in the derived class is invoked. Before example, the function in the base class is invoked. Now the function in the derived class is invoked using the base class pointer by using the virtual keyword.